I'd like to introduce the idea of functions in Objective-C now. Functions are something that you might be familiar with if you've taken a math class, particularly an algebra class. In a lot of ways, functions in code are a lot like math functions. If you remember the definition of a function from math class, you might remember something like this, where y equals f of x. This is a mathematical notation for a function, and it has a sort of an analog to the way things work in code. Some of the features of a mathematical function are that it has a name. In this case, the name of our function is f. Our code also has some inputs. Input into this function is x. We're going to give x to the function f, and it's going to produce something. And what it's going to produce is going to be the output y. Functions also have a definition. So in this case, the function f of x is defined by a body which says 2 times x minus 1. This is an example of a possible definition of f. It's also possible for functions to have more than one input variable. For example, this function has 3 input variables, x, a, and b. And the definition of the function includes all of those variables in order to produce y. In this case, it's the equation of a line, a times x plus b. Those multiple inputs are necessary in order to compute the output. So in a mathematical sense, we know that a function has some properties. It has a name, it has 0 or more inputs, it has 1 output, and it has a definition. Well, in code, it's similar. Code functions also have a name. We've seen names already when we have defined variables. For example, when we define integer a equals 0, we know that there's a variable called a, and that a is that variable's name. Int is its type. Functions also have a name like that. We know that mathematical functions have 0 or more inputs. Well, inputs to functions you can have 0 or more inputs to functions as well, code functions. And those inputs are going to be variables, like a. Functions also output something. It can have 0 or 1 output. Those outputs have a type. And then finally, functions also have a definition. And that definition is defined by lines of code that are within it. So let's look at one that we've already seen. We've already seen in previous examples the function main. We haven't really looked at it in detail, so let's break it down into the different components. So for starters, the main function has a name, and the name of the main function is main. And you can see it here. That's the place in the syntax where the name of a function goes. Functions also, as we said, have a body, and the body is the code that defines it. And in this function, it's the loop with the 3 printf statements. Functions have an output. This main function, and all main functions in C, Objective-C, have a type of int, and that's located here. It's before the name of the function. And then the value of the value that gets returned as output, not just the type, is defined by a return statement. And in this case, we're returning 0 and saying 0 is of type int. So the output's broken into 2 places. Our inputs in this case are called argc and argv. Those are the names of 2 variables that are coming into our function. So main is a function and has all these different components, very similar to the mathematical functions that we've looked at so far. To make that connection, we can put the mathematical formula next to the code, and we can draw a line and show you that in a mathematical function, the name of the function is f. In the code, that name is main, and here's where those 2 things match. Functions also have inputs, so here's an input, and here's another input, mapping a and b to argc and argv. Functions have an output. Now in code, the output is split into 2 types. One part is where you define the type, that's next to the name, and the other place is where you define the value that's returned, and that's next to a return statement, somewhere within the body of the function. Another way that you can think about a function is to think about it maybe in a box and line diagram. So you can think about it as a flow of data going through a box. And that box is the function, and within that function is code. The inputs flow into the box, the code does something to the input, and that data flows out as a result. In our case, the inputs were in the case of the main function, the inputs were argc and argv. The code statements were printf statements. The output was of type int, and the name of the function was main. So you can also think of it in this way, in a box and line diagram. So let's take a second, let's write our own. What we're going to do is we're going to write a function whose name is going to be day greeting. It's going to take 1 input, and it's going to have 0 outputs. We're going to do this to test our understanding of the syntax of a function. So here's the function that we've been working with. It's the main function. It has a loop that writes 3 lines, good morning, good afternoon, and good evening in a row, with 3 different, with the number of times indicated by the loop. What we're going to do is we're going to write a definition of a new function called day greeting. We're going to give it a return type of void. That means there are no outputs. And as an input, we're going to have one variable called loops, which is of type int. Within the body of our function, we're going to take the code that was in main and we're going to move it up into this new function that we're going to create. We're going to create a loop that rather than going from 0 to a hard-coded number like 2, we're going to go until I is no longer less than the variable loops. That was the input to the function. But otherwise, this code is going to be exactly the same. Then, when it comes time to call this function, we're going to call it with the number of times we want the greetings to be written out using the printf statements. And we'll do that by replacing the original lines of code with a call to the function. You can see that blue marker there. I accidentally indicated a breakpoint. We'll talk about that in future videos about breakpoints. In this case, we're just going to get rid of it here. So now when we run this function, the main function is going to get executed. Day greeting will get called. The number 2 will be passed to the function we just created, and those loops will get executed. That loop will get executed 2 times, writing 6 lines of code. And when we execute it, you can see that's exactly what happens. So what we've done here is we've defined our own function. It has a similar format to the main function, only it's using terminology, or it's using sort of variables and types that we're more familiar with. So why would we want to do this? Why would we want to write functions that encapsulate several lines of code in one logical unit? Well, our big reason is reusability. There are oftentimes tasks that you want the computer to do over and over and over again, maybe with small changes that can be accommodated by an input variable, like the number of loops in our example. And rather than writing that same code over and over again and possibly introducing errors, we can write that code once, and anytime we want to use that functionality, we'll call the function. As a side note, this also improves our abstraction. We don't have to think about the details of writing those 3 lines each time we want to call day greeting. We can just abstractly think of making the day greeting call, function call, and not think about the details so that we can use that as a building block for bigger and bigger projects that we might want to work with. There are a couple side notes that I need to bring your attention to. When I described a function as this box, it's kind of like it was a black box where we have these inputs going in, code get executed, and output comes out. Well, in reality, the code that gets executed within these functions can sometimes have something called side effects. Without side effects, you would assume that the only thing that this function is doing is writing an output. Well, side effects mean that that function might do something else in the world other than just return a value to the output. And we've already seen that. For example, a side effect of the day greeting code was that it wrote out good morning, good afternoon, and good evening to the console. That's a side effect of that function that didn't just have to do with the value that it returned. And where the value in our case was nothing, it was void. So sometimes a function changes things besides just its output. That's called side effects. And this is very common, but it's kind of a little bit different than maybe that diagram suggests above. Secondly, sometimes it's useful to write down the first line of a function describing its inputs and its output and its name without declaring the body of the code immediately. This is the difference between a definition and a declaration. Sometimes you need to just name the function without providing the code for it. And this is called a declaration. This is where you don't describe what's going on inside. Now, this isn't very helpful for your code at the end, but it's very helpful for the compiler, especially when function A calls function B and function B calls function A. Because you have a circular condition here, you have to declare one of those functions before you describe the code for it. So you may run into cases where you see functions that are declared but don't have a body defined in them. And that's just called a declaration. It says that here's a placeholder. In the future, I'm going to have to put in the actual body of that function before I can use it. So in summary, a function is a way to encapsulate some common code. A function can have multiple inputs, and a function can have 0 or 1 output. Functions are really important for abstracting repetitive work that computers do. In the next lecture, what I'm going to bring up is some more information about functions and some of the ways that calling functions repeatedly can impact our computing environment. Thanks.